Good afternoon, everyone. Ram Kumar?
Ma'am, good afternoon,
Yeah.
madam.
Good afternoon, Ram Kumar. You have joined, right?
Yes,
Okay,
ma'am.
thank you. Thank you so much. Sir, we start the program. Now I
Okay,
hand over the
ma'am.
session to Aarti ma'am to welcome the gathering and also the chief guest introduction.
I welcome you all for the section level artificial intelligence and cloud services. Today we have an excellent speaker, Dr. S. Ram Kumar, working as an associate professor at Christ University, Bangalore. He has 11 years of teaching experience and 9 years of research experience. He has published several papers in referred journals and conferences. His field of interest is biosignal processing, artificial intelligence, human computer interface, brain computer interface, and mission. He is an editorial board member and a reviewer of the several SCI, SCIE, and Scopus Index journals in India and various other countries. He has published several articles in SCI and Scopus Index journals. He has also acted as chairperson and keynote speaker in several international conferences, and he has trained many students, faculties, and school teachers with latest technologies. And he has received gold medals, silver, and bronze medals in national and international exhibitions for his research projects on mission, vision, and human computer interface. He has also filed 2 patents. He has received funds from the funded agencies like DST and CSIR with a worth of 32 lakhs. And he is the author of the textbooks Java for Beginners, a Magic Book of Quantitative Aptitude and Reasoning, and Problem Solving using C and C++, Basics of Internet with Web Designing and Deep Learning. On behalf of our institution, it's my privilege to welcome you, sir. I now request, welcome sir. I now request Dr. S. Ram Kumar to take over the session.
Okay, thank you, ma'am. Thank you, ma'am.
Thank you, sir.
Please give the sharing option, ma'am.
Sharing, I can, you can present it here, sir. You can, in your meet, there's a, yes, we have stopped.
Okay, now, ma'am. Can you able to see my screen now? Participants?
Not it, sir. Yes, sir, now it's visible.
Okay. So, good afternoon to all.
Good afternoon.
Okay. So, today I'm going to discuss about the learning process of neural network. So, before going to this topic, what is the roadmap of the today's study? If you see, we are going to discuss about what is meant by neuron and what are the components that are present in the neurons, and then how your information is going to transmit from source to destination, and what are the properties that neuron have. Then
Sir, sorry for the interruption. Your screen is not visible, sir.
wait, madam, I'll put. Now, madam?
Yes.
Yes, sir. Now it's visible.
Okay.
Sir, but it's It's not.
Blinking, no?
Yeah, it's blinking.
Then 1 minute, madam. Then I will connect it with our LAN connection. Okay,
Okay,
I'm
sir.
connected with my mobile phone, so
Okay,
only
sir.
it's I think so.
Okay, sir.
Now it's okay for you all. Don't know why the screen is like this.
So now also it's blinking.
Don't know why it's happening. Okay,
Yeah,
now
now
it's
it's
okay.
okay.
I don't know why it's happening. Okay, so in the okay. So in the today's class, we are going to discuss about the learning process of the neural network. So in the roadmap, we are going to discuss about what is meant by neuron, what are the components that together to form a neuron, how information is going to transmit from the source to destination, and what are the different types of neural networks are available for us, and what are the we are classifying the architecture of the neural network, and then how learning is going to take place in the neural network, and how we are going to implement this neural network concept in the artificial intelligence. This is the roadmap today we are going to discuss. So before going to the this session, we need to know what is meant by neuron first. Okay. So if it is a neuron is called as a Greek word which indicates the nerve cell. So it is one of the important fundamental unit of the brain. Why we are calling this as a important fundamental unit of brain means the brain is totally made up of n number of nerve cells. So we are calling this a neuron is a fundamental unit of the brain. If you take a neuron, it is going to communicate in two ways, both electrical as well as chemically. Okay. So we are going to call this as a electrical signal and the chemical signals. The electrical signals are the axons potential which transmit the information from one of the neuron to the other. The chemical signal are a neurotransmitters which transmit the information from one neuron to the next neuron. So the neuron we are going to call as a biochemical process is going to take place in the neuron. With the help of this biochemical process, the transmitting from the source to destination is possible. Okay. So if you
Uh,
take a
sir,
neuron,
1 minute. Sir, 1 minute. Sir, again the screen is not visible, sir. Uh, or else can you send us the PPT, sir? We present it?
okay, no issue. How can I
Okay.
send you the PPT?
You can send it to it@srcas.ac.in.
What's the mail ID, madam? IRQ.
IT
IT
at
at
srcas.ac.in.
IT. Madam, IT at
IT at srcas dot
SRCAS dot
srcas dot
uh,
ac dot
AC
in.
dot.
In.
Okay, 1 minute. I check. I sent, ma'am.
Yes, sir. Yes, sir. I'll check, sir.
It is from my official mail ID. If it is not there, please check in the spam.
Okay, sir. Okay.
I hope that now the screen is visible to you all.
Yes, sir. Now it is visible.
Yes, I will make the some full screen mode.
Okay, sir.
Okay.
Sir, you proceed. If there is any problem, we will share it, sir.
Ah, okay, okay. Okay. So now, if you take a neuron, these are called as a specialized cell. Why we are calling this as a specialized cell? If you take that, its size is very, very low, and also its size is on less than 100 micron. So 1 micron is equal to a 1 millionth of a meter size. So it's a very, very tiny cell. This tiny cell contains the important components like dendrite, soma, and then axon. Using these three components, it is going to make some communication from source to destination. Okay. If anybody asks you what is meant by a neuron, the general definition for the neuron is a neuron is a complex biochemical and electrical signal processing unit. It's going to receive the signals in the form of chemical as well as electrical signals and combine these signals, and it is going to give the input to the another neuron through dendrites. Okay. So what is the main use of this neuron means it is going to collect chemical signals as well as electrical signals and combine these signals and giving the information to the another neuron. Now the same another neuron is going to get this input and it is going to do the same process again and it is going to pass the same information to the next neuron. So this is the procedure is going to happen from source to destination. If you take a biological neuron, it consists of important 3 points are there. They are called as an dendrite, soma, and the axon. There are several components which are present in the biological neuron, but we are going to consider only these three. Why we are considering these three means these three is going to do major activities in the neuron. That's why we are going to consider only these three components of the biological neuron. They are dendrites, soma, and then axon. Okay. So what is the main use of this three part in the neuron means it is going to receive a electrical signal as well as a chemical signals. The electrical signal is called as an axon potential, which is going to transmit the information from one neuron to another neuron, as well as the chemical signal is going to transmit the information from one neurotransmitter to another neurotrans receiver. So each and every neurons have a neurotransmitter as well as a neuron receiver. Okay. So if you take the biological neuron, it consists of three important components called as dendrite, soma, and then axon. Okay. So this is the macroscopic view of a biological neuron. If you see, it's look like a tree structure. Okay. So if you take this structure, I divided this structure into three components. They are dendrites, soma, and then axon. So this is the macroscopic view. So this is called as only one neuron. So this neuron is connected with the another neuron with the help of incoming axon from other neuron. So I focus only one neuron in the macroscopic way. The next view is called as a microscopic view. Okay, this is on a microscopic view. If you see that dendrites, soma, and then axon is present in this. Okay, the synapse is there. It's called as a neurotransmitter is there. We are going to discuss in the next upcoming slides. Okay. So now what is meant by dendrites? Okay. So dendrites is nothing but an, if you take a dendron, means it indicates a tree-like structure. Okay, so this contains the major body of the neuron is going to receive the input. Maximum, if you take a human body, maximum amount of input is going to received with the help of this neuron. Okay, so if you take the dendrites, it's a tree-like structure. That's why they are calling this as a dendritic tree structure. Okay, so if you take all kind of neural network, the input is going to takes place in the form of input layer. Likewise, here if it is a biological neuron in the living organism, all the inputs are going to takes place from this dendrites. Okay. See the first point, the dendrite of a neuron or cellular extension, it consists of many branches, and if you see the structure, it's look like a tree. That's why they are mentioning this as a dendritic tree. So what is the main work of this dendrites? If you see, the dendrite is going to receive all inputs from the neurons. Okay, from the external areas, receive the signal. The next one is called as an soma. Now, if you take a soma, it's a main body of the neuron. Why we are calling this as a main body of the neuron? If you take that, it is the dendritic trees and axons are connected with the help of this soma. Okay. So if you take a soma, it is a pyramidal structure. You are going to see in the next slide. See, this is the soma. So dendritic tree is fully occupied with this soma. Okay, so it's look like a pyramidal or cylindrical shape. Depends upon the shape of the neuron, it will be vary. Okay. So in the, if you take this soma, it's going to get all the input signals whatever received by the dendrites. So what is the work of this soma? If you take that, whenever all the inputs are collected, the soma start to sum all the incoming signals. Whenever the sufficient input is reached, then automatically the neuron which is present in the network is start to fire. Then immediately the impulse is going to take place. So what's mean by impulse? We are going to forcefully, we are going to move the body from one point to another point, then you are going to call that as an impulse. Likewise, one neuron, whenever the neuron start fires, then immediately it is going to kick the next neuron, and then the next neuron is going to get fire, and then again it is going to kick to the next one. Likewise, the motion impulse is going to take place from the soma. Okay, so now dendrites is going to receive all the input from the external environment. Now the soma is going to collect all the inputs. Whenever the sufficient input is reached, immediately the soma start to fire. Now the neuron movement is going to take place, which means our signal is going to move from one place to another place. Likewise, it is going to connect from source to destination, and it is going to the next layer called as an axon. Okay. See the axon. So what is the work of the axon? If you see that, the axon is going to connect the one neuron with the another neuron. So here the signal transmission is going to take place from one neuron to another neuron. So if you take the axon, each neuron in the brain has one long cable that snakes away from the main part of the cell. What is the work of this means? It is going to transmit the signal from one neuron to another neuron. If you take the total size of the axon, it is lesser than that of the human hair. Okay. So now this axon is having in a different lengths, depends upon the size of the neuron. So the connection point between your two neurons is going to occur with the help of this axon. Okay, now we in the previous slide we discussed about one neuron and its internal structure. Now one neuron connected with the another neuron with the help of this axon. Okay, now the dendrites received the input signals, soma collect all the input signals, then whenever the sufficient input is reached, the neuron start to fire. Immediately the signal is going to move from one place to another place through axon. Now axon is going to give the input to the another neuron. So in between this axon, one more thing is there called as synapse. We are going to discuss in the next slide. Okay. So if you take an axon, it is a nerve fiber and also it is a portion of a nerve cell which is going to carry the electrical or chemical signals. Okay. Now, so what is meant by synapse? Okay. Neuron communications with one another at junctions are called synapse. Okay. At a synapse, the neuron is going to send a message to your target neuron or another cells. Okay. So now axon, if you take a single neuron, it consists of three important parts called dendrites, axon, sorry, soma, and then axon is there. Likewise, all neurons have this same three parts. Now one neuron start to fire and another neuron is there in the another place. Now these two neurons are going to connect with the help of the axon. Already I told you that. So now in the axon, the synapse is present. What is the use of the synapse means? It is going to join the two different neurons. That's the main work of the synapse. Okay. So most of the synapses are chemical signals. The synapses communicate using the chemical messengers. Other synapses are in the electrical one. Okay. So now the ions are flow directly between these cells. So through these ions, the connection between a one neuron to another neuron is going to takes place. Okay. So at a chemical synapse, an action potential is going to trigger. If you see the next diagram, then you will know. See here, presynaptic synapse and then postsynaptic synapse is there. Okay. So now the action potential is going to come from the presynaptic cell and the synapse is going to connect with the two neurons. Another one, those who are receiving that signal from the previous one, we are going to call as an postsynaptic. On those who are generating the electrical signal, we are going to call them as a presynaptic cell. Okay. So these two different neurons are connected with the help of this synapse. Okay. So if you take a synapse, see the impulse signals are transmitted across a synaptic gap by means of some chemical process. So this depends upon this chemical process. One neuron is going to connect with the another neuron with the help of this synapse. So one synapse consists of neurotransmitter and another one neuron consists of neuro receiver is there. So transmitter is going to transmit the signal, receiver is going to receive the signal. Likewise, the synapse is present in between the two neurons. By passing this signal, transmitter and receivers are directly connecting. So if you take a single neuron that consists of 1000 to 10,000 synapses, and each and every synapses are connected with a 1000 neurons. So totally there are 100 billions of neurons in our brain, and each neuron has a 1000 dendritic trees. So the bio communication channel is very fast compared to that of the artificial process. Okay. So now I'm going to display some video for you. How the 1 minute wait. I'll display the video.
Ouch! Gotcha.
Can you able to see the video now?
Yes, ma'am. Yes, I will.
Pain, although often
Yeah, it's okay.
protective mechanism.
Yes.
Ouch! Gotcha. Ouch! Gotcha. Pain, although often uncomfortable, is a protective mechanism that alerts us to potential or actual harm to the body's tissues. Here, the peripheral nervous system sent a pain message to the brain that a bee sting occurred on the nose. Let's take a look at an instant replay to see how this communication works. The pain receptors in the skin detect tissue damage from the bee sting. Then, the peripheral nerves send a pain signal to the brain. The brain analyzes the pain signal. Ouch! In turn, the brain delivers a message of the arm.
Ram,
Ma'am? Madam?
வேற ஏதோ வீடியோ மாதிரி play ஆகுது.
Yes, ma'am. Video only and display. I am showing the video now.
ஓ, ஆனா
How
இப்போ
signal,
இதுல வரல.
how signal transmitting from source to destination.
ஓகே, வீடியோ அந்த வாய்ஸ் இருக்கு, ஆனா பட் அந்த வீடியோ வரலையே ஸ்கிரீன்ல.
Now, madam?
இல்ல ஷேர் ஆகல. வீடியோ ஷேர் ஆகல.
Pain, although
Wait, madam. I display separately now.
ஓகே.
Now, madam? Is displaying to all?
Yeah. This thing, some word video is coming. No, that. Okay, you just play the video. Yeah, now it's
Okay.
pain,
yes, it's
although often uncomfortable, is a protective mechanism that alerts us to potential or actual harm to the body's tissues. Here, the peripheral nervous system sent a pain message to the brain that a bee sting occurred on the nose. Let's take a look at an instant replay to see how this communication works. The pain receptors in the skin detect tissue damage from the bee sting. Then, the peripheral nerves send a pain signal to the brain. The brain analyzes the pain signal. Ouch! In turn, the brain delivers a message back to the muscles of the arm to react. Gotcha! Hasta la vista, baby.
Okay. So now we saw one video, no? So how the signals are transmitting from the source to destination we discussed. So all this source to destination transmitting messages are took place with the help of this neuron, and the synapses are connection in between the two neurons. So our information is going to transmit from source to destination. So what are the properties of the neuron? Can you able to see my presentation slide now?
Yes.
Okay. So signals are received by the processing element. So what are the properties are there for neurons means? So the neuron is going to receive the input signals, and it is going to sum the input signal with the weight. This is the first step. Then second step, according to the input, the network is going to change the weight according to the parameter whatever you are going to give. This is the second property of the neuron. Then third property, whenever if you receive the sufficient input, then automatically the neuron start to fire. This is the third property of the neuron. And fourth one, now after firing, our input is transferred to the output. This is the fourth one. Then if we find any error in the output, then automatically the weight is going to back propagate again. Then the weight is going to modify according to the inputs given by the back propagation algorithm. So we are going to call this step as a experience. So if it is a neuron, it consists of this following 5 properties. Okay, it is common for all the biological neuron as well as a artificial neuron. So if you take both the neuron as a artificial neuron, or if it may be a biological neuron, both have the inbuilt fault tolerance. So what's mean fault tolerance? Even though if 100 students are there in the class, even though if one or two make a mistakes, we are going to eliminate the two, and then we are going to focus the 98 students. We are going to call this as a fault tolerance, which means you are going to connect a computer system in the bus network. Even though if any one of the two system will be not work, okay, the remaining system is, we are going to focus the remaining system. Example, if it is a hub network, okay, so the centralized server is there, they connected with the remaining server systems are connected. If any one of the system is not working properly, then we can able to access the remaining system very easily. Likewise, if any fault turns any of the component, the 3 components, no, called as an dendrites, soma, and then axon is not working properly, it's going to fault tolerate the following components, and then it is going to give the output in any way. So now we are going to discuss about whatever thing we discussed till now. Its display is it is present in this following video. Now again I am going to display the one video for you now. Madam, can you able to see my video, madam?
Yes, yes, doctor. Yes.
Command center for the entire body. It makes us who we are. It receives information from our senses and controls our thoughts and movement. To better explore this incredibly complex organ, scientists have divided it into parts and regions. The largest part is the cerebrum, which is divided into 2 sides called hemispheres, just like the Earth. The outer layer is known as the cortex, which is Latin for bark. Like a tree's bark, the surface is only 1/8 inch thick, but it also contains millions of cells with fibers that send messages to other brain areas. More than 2/3 of the surface of the cortex hides in hundreds of little folds that make the wiggly visible lines on the brain. Animals that are less intelligent have a smoother brain surface. The cortex is divided into 4 regions. The frontal lobe is for personality and emotions, higher thinking skills like problem solving and controlling movement. It continues to develop until you're in your mid 20s. The temporal lobe helps process your hearing and other senses and helps with language and reading. The parietal lobe is involved with your senses, attention, and language. The occipital lobe helps your eyes see, including recognition of shapes and colors. The thalamus in the center of the brain relays sensory and motor information to the cortex and helps with consciousness, sleep, and alertness. 12 pairs of cranial nerves carry information from your senses to and from the brain and body. Lower in the brain, we find the cerebellum, which plays a key role in motor control, coordination, spatial navigation, so we can find our way out of a maze, for example. Underneath is the brainstem, which connects the brain to the spinal cord, a nerve pathway that runs all the way down your back, sending and receiving information from your senses. The brainstem includes the pons, which helps control our breathing, and the medulla oblongata, which regulates our heart and other body reflexes like vomiting, coughing, sneezing, and swallowing. The limbic system, a region under the cortex, processes our emotions and drives. It contains the brain's reward circuit, which releases the chemical dopamine, making us feel pleasure. The anticipation of pleasure motivates us to repeat important human behaviors like eating, having fun with friends, or falling in love. But it also encourages us to repeat risky behaviors like taking drugs. Drugs signal the brain to release unusually strong amounts of dopamine. This flood of dopamine causes the high that drug users seek and makes it difficult to enjoy more normal, simple pleasures. Repeated activation of this reward pathway can lead to addiction. The limbic system includes the amygdala, which processes emotions, and the hippocampus in the temporal lobe, which is like a memory indexer that sends memories to certain parts of the brain for storage and retrieves them when you need them. The brain controls many actions through rapid nerve impulses, but there are some body functions that the brain modulates over many hours or days by secreting hormones via special glands like the hypothalamus, which wakes you up in the morning and gets the adrenaline flowing, like during a test or athletic event. The pituitary gland, often called the master gland, which helps control growth, body temperature, pregnancy, and childbirth. And the tiny gland, which helps to control sleep and circadian rhythms. These are just a few of the parts and functions of the beautiful, amazing, and complex human brain.
Okay. So I hope that you all are know what are the body parts controlled by which part of our human brain. If you see the next video, then you can able to know what is meant by our central nervous system. Then we will enter into the artificial neural network. Can you able to see my video, madam, now?
Yes, sir.
Okay.
Yes, we can.
Central nervous system. Introduction. Ever thinking of? You are correct. Your brain runs the show and controls just about everything you do, including those activities which are going on inside your bodies. All such actions have to be properly timed and coordinated, which is done by the nervous system and the hormonal system. Let's understand the nervous system. The nervous system is an organ system containing a network of specialized cells called neurons that coordinate the actions of an animal and transmit signals between different parts of its body. The nervous system is divided into two main systems: the central nervous system, that is CNS, and the peripheral nervous system. The spinal cord and the brain make up the CNS. Its main job is to get the information from the body and send out instructions. The peripheral nervous system is made up of all the nerves which transmit the messages from the brain to the rest of the body. The peripheral nervous system connects the CNS to sensory organs, such as the eye and ear, other organs of the body, muscles, blood vessels, and glands. The central nervous system is comprised of the brain and spinal cord, which is located in and protected by the skull and the vertebral column. Neurons are the basic building blocks of the nervous system. These specialized cells are the information processing units of the brain, responsible for receiving and transmitting information. Each part of the neuron plays a role in the communication of information throughout the body. Let us learn the structure of a neuron. A neuron has three basic parts: the cell body, the axon, and the dendrites. Cell body contains a well-defined nucleus surrounded by a granular cytoplasm. The cell body is also known as perikaryon or cyton. Dendrites are branched cytoplasmic projections of the cell body. They are for receiving impulses from the axon of another neuron. Dendrites of one axon of the other neuron are separated by an extremely narrow space called the synaptic cleft. Through this synaptic cleft, nerve impulses are transmitted. The axon, also called the nerve fiber, is a long process of a neuron cell body. The axon is specialized to carry messages. An axon of one neuron may have enough branches to make contact with as many as 1,000 other neurons. Axons are covered by a protective layer of a white insulating sheet called myelin sheath. The myelin sheath shows gaps throughout the length, which are called nodes of Ranvier. The end portion of axons have swollen bulbs called axon terminals that store certain chemicals called neurotransmitters. There are three different types of neurons. The first one is sensory neurons, which carry impulses from the sense organs to the central nervous system. The second type of neuron is motor neuron, which carries impulses from the CNS to muscles or glands of our body. And the third type of neuron is interneuron, which connect various neurons within the brain and spinal cord. It carries information between the motor and sensory neurons. Did you know that the brain is the most complex organ in the human body? Let us learn more about it. The brain is the center of the nervous system.
So now I hope that you all are know what is meant by biological neuron. Now I am going to compare all the biological neuron components with the artificial neuron. Okay. So what are the components we already discussed in the biological neuron? No? Dendrites, soma, and then axon. Here, in the same three components are present in the artificial neural network with different name. What are the different name we given for the artificial neural network? We are going to discuss in the slides. with different weights. Then bias is going to add. Whenever the bias is going to add, then automatically it's going to, and the activation function is going to apply in that. Then automatically, yeah, it is going to create a network model. So if you take a activation function, it may be a binary or it may be a bipolar. Okay, depends upon the activation function. The network is going to give different output for us. Okay, so this is the mathematical model. If you see this mathematical model, one video is there. I'm going to play that video now.
Neural networks are algorithms that are based on the way the brain works. They can build predictive models by learning the patterns in historical data. Neural networks are made up of small, interconnected processing elements. These elements are called nodes. Each node processes a small part of the task. The most common type of neural network is called a multilayer perceptron. In a multilayer perceptron, the nodes are organized in layers. The first layer is called the input layer. The outermost layer is termed the output layer. Between these two come one or more layers. These are called hidden layers. The input layer receives the values of the independent variables as input. The nodes of the hidden layer take their inputs from the input layer, process it, and pass it on to the nodes of the output layer. This is what happens within a node. A node receives information from multiple nodes of the previous layer. These are multiplied by unique weights and added together with a small value called a bias. This total is processed by a function called the activation function and leaves the node as output. This process proceeds till information reaches the output layer and leaves it as a prediction for the dependent variable. The network then compares the prediction with the actual value of the dependent variable. If these do not match, it adjusts all the weights in the network and repeats the process. These iterations get repeated till the neural network is able to produce accurate predictions for most of the observations. Once this is achieved, we are left with a neural network model that can be applied to a new set of data to provide predictions. Thank you for watching this.
Okay. So this video discuss about that. We are going to give the input. Automatically weight is going to add. Then bias is going to take place. And then activation function. Now if you apply the activation function, then automatically input neuron terminal towards a output neuron. Okay. In the activation function, we are going to fix the binary or bipolar. Binary is nothing but we have only two states. If it is a bipolar, then it has a three state called as 0, 1, and then -1. Okay, depends upon this activation function, the neural network mathematical model neural network is going to give us an output. Okay, so finally when the neural network learning is stopped, when stop means whenever the actual output is equal to the desired one, then automatically the network is going to stop the learning process. Till up to that it is going to continue. So what are the three parameters? Very important parameters are there for declaring the artificial neural networks are. The first one is the interconnection pattern between different layers of the neuron. If you take a architecture of the neural network, it consists of input layer or hidden layer and then output layer. The interconnection between the different path, which means from the input to output layer, we can able to give n number of hidden layer or a single hidden layer, or it may be directly one input or directly from one input to output. Okay, so depends upon the interconnection patterns and the layers whatever you are going to implement in the neural network. Okay, so this is the first parameter. Then second parameter is the learning process. Whatever learning algorithm we are going to apply for the network to learn, depends upon that it is going to process the weight. This is the second parameter. Then third parameter is an activation function. I told you that depends upon the activation function, whether it is a binary or bipolar, depends upon that the neural network model is going to generate the output for us. At the time of designing the neural network, we must take care about that following these three parameters. One is called as an interconnection between the layers, and then learning algorithm what we are going to use, and what is the activation function we are going to set up in the neural network model. We need to take care about this three parameters. Now, architecture of the neural network. Already, I hope that you all know what is meant by architecture. Architecture is the internal arrangements of the layers. You are going to call that as a architecture. Okay. So the arrangements of neurons and its interconnection pattern within the layers. We are going to call this as a neural network architecture. Neural network architectures are designed in three components. They are input layer, hidden layer, and then output layer. The same thing, whatever we discussed in the biological neuron is coming here now. Okay, their dendrites is equal to input layer here, and hidden layer is equal to soma there, and output layer is equal to axon in the biological neuron. Okay, so what is the work of the input layer means? It is going to receive the input alone from the source. Okay, now what is the use of the hidden layer means? If you take a hidden layer, all the calculation is going to take part in this hidden layer, because if we give the input, or we are going to give the input alone in the input layer, from the input layer to hidden layer, it is going to add the weight. Now weight is mingled with the input whatever you are going to give. Okay, so now the calculation is going to take place in the hidden layer. Now here bias is going to add. Okay, now after this, after applying the activation function, now automatically the information is passed towards a output layer. Now through the output layer, we are going to receive the output. Okay, so this is the architecture of the artificial neural network. I hope that now you all are know why I discussed the dendrites, axon, and the soma, and then axon. So the same three layers we are giving the name artificial. We are giving the name as an input layer, hidden layer, and then output layer in the artificial neural network. Okay. So now,
Last summer, my family and I visited Russia. Even though none of us could read Russian, we did not have any trouble in figuring our way out. All thanks to Google's real-time translation of neural networks form the base of deep learning, a subfield of machine learning where the algorithms are inspired by the structure of the human brain. Neural networks take in data, train themselves to recognize the patterns in this data, and then predict the outputs for a new set of similar data. Let's understand how this is done. Let's construct a neural network that differentiates between a square, circle, and triangle. Neural networks are made up of layers of neurons. These neurons are the core processing units of the network. First, we have the input layer, which receives the input. The output layer predicts our final output. In between exist the hidden layers, which perform most of the computations required by our network. Here's an image of a circle. This image is composed of 28 by 28 pixels, which make up for 784 pixels. Each pixel has input to each neuron of the first layer. Neurons of one layer are connected to neurons of the next layer through channels. Each of these channels is assigned a numerical value known as weight. The inputs are multiplied to the corresponding weights, and their sum is sent as input to the neurons in the hidden layer. Each of these neurons is associated with a numerical value called the bias, which is then added to the input sum. Is then added to the threshold function called the activation function. The result of the activation function determines if the particular neuron will get activated or not. An activated neuron transmits data to the neurons of the next layer over the channels. In this manner, the data is propagated through the network. This is called forward propagation. In the output layer, the neuron with the highest value fires and determines the output. The values are basically a probability. For example, Here, our neuron associated with square has the highest probability. Hence, that's the output predicted by the neural network. Of course, just by a look at it, we know our neural network has made a wrong prediction. But how does the network figure this out? Note that our network is yet to be trained. During this training process, along with the input, our network also has the output fed to it. The predicted output is compared against the actual output to realize the error in prediction. The magnitude of the error indicates how wrong we are, and the sign suggests if our predicted values are higher or lower than expected. The arrows here give an indication of the direction and magnitude of change to reduce the error. This information is then transferred backward through our network. This is known as backpropagation. Now, based on this information, the weights are adjusted. This cycle of forward propagation and backpropagation is iteratively performed with multiple inputs. This process continues until our weights are assigned such that the network can predict the shapes correctly in most of the cases. This brings our training process to an end. You might wonder how long this training process takes. Honestly, neural networks may take hours or even months to train. But time is a reasonable trade-off when compared to its scope. Let us look at some of the prime applications of neural networks. Facial recognition. Cameras on smartphones these
Okay. So now I hope that you all are know what are the importance of this three layer in the artificial neural network, because the input layer, all the input is going to take place. Hidden layer is going to perform all the calculation. Output layer is going to give the output for us. Okay. So now you need to map this with the biological neurons. Three components called as on dendrites, soma, and then axon. That's why I gave more important for that three components in the previous slide. So now I am compared that three layers here also. Okay. So now, if you take a architecture of the neural network, there are two architectures are there. One is called as on feed forward and then feedback neural network. Okay. So if it is a feed forward network, it is called as a dynamic neural network. Why we are calling this as a dynamic static neural network means the input is going to flow only in the forward direction called as an input to hidden layers and hidden layer to output layers. There is no feedback connection here. That's why we are going to call this feed forward network is a static network, because the dynamic changes are not able to catch at the time of this feed forward neural network or the static neural network if you are applied at the time of finding the solution for your problem. Okay. So why we are calling this as a feed forward? If you take that, signals are going to transmit in the form of forward direction alone from input to hidden and hidden to output layer. Sometimes your network architecture is in a single layer network. Your information is going to transmit from input layer to output layer directly. So depends upon the architecture, the feed forward network also differ, because if you use a n number of hidden layers in between the input to output layer, then you are going to call that as a multi-layer feed forward neural network. If there is only one input layer and then one output layer is there, then you are going to call that as a single layer feed forward neural network. Okay. So now the strength of the what is the main use of this feed forward neural network means, yeah, if you give the input pattern, it's going to process the input and finally it is going to give you the output. And then these neural networks are classified into two different categories. One is called as a single layer neural network and another one is called as a multi-layer networks. Multi-layer neural networks. How you are going to classify this? If you see this, okay. If you take a architecture, it contain only nodes, input nodes, and then output nodes. Then you are going to call that as a single layer neural network. Okay. So in between this is the diagram for the single layer neural network. You are going to give the input, then finally it is going to give you the output. There is no hidden layer in this architecture. Then you are going to call this architecture as a single layer feed forward neural network. Okay. So the single layer neural network consists of one layer of connection weights. Then you are going to call this as a single layer feed forward neural network. Okay. So the net consists of layer of units called input layer, which receive the signal directly and it is going to give you the output directly. Then you are going to call this as a single layer. So here one more video is there. We need to discuss this first one. Why we are using this feed forward neural network? Okay, where we are going to apply this feed forward neural network? Okay, at the time of pattern generations and then pattern recognition and then classification, whenever if you need, at the time we are going to use this feed forward neural network. Okay, at the time of calculating the total number of layers which is present in the neural network, we are going to calculate the hidden layer and then output layer, because the input layer just it is going to perform the input alone and there is no calculation is going to take place in the neural network. So we are going to calculate the layers, number of layers from the hidden layers and then output layer alone. Okay, so because there is no action is going to take place in the input layer. Okay.
Code Academy is a great tool for anyone looking to increase their skill set.
See, this video indicates that how our input is converted to an output, how it is going to back propagate the error signals again and finally it reaching the in output. So this iteration is going to take place up to 2000. So each and every iteration the value is going to change. See, the hidden value is changing for each and every iterations, because this indicates that input mingle with the weight, so that automatically the network is going to adjusting its parameters, adjusting its weights. You are going to call this as a learning. See here, back propagation takes place again. So up to 2000. See, finally. Okay. So likewise, it is going to back propagate the signals again and again up to that actual output is equal to the desired output. Now multi-layer network. How can we tell that multi-layer network means one input layer, several hidden layer and one output layer is there. Then you are going to call this architecture as a multi-layer feed-forward neural network. So if you take the multi-layer neural network, all the following layers are cascading. What is meant by cascading? The cascading indicates that it is on joining of more than two layers. So all the layers are joined together. If you see the architecture in the next slide, then you will know that, see, this is the hidden layer is there. So you are going to keep one more hidden layer again and again, like that you can able to keep n number of hidden layers in between the input layer to output layer. Then you are going to call this as a multi-layered feed forward neural network. So now the output of one layer is going to provide the input to the next layer. Example, if you see this, input layer is going to give the input. Now weight is going to add. Now input, weight added to the added, and it's going to process by the hidden layer. Now if you take the hidden layer, input and then weight is added with the hidden layer, biasing, then activation function. With the help of activation function, it is going to produce the output for us. The second architecture is called as an feedback architecture. If you take a feedback architecture, there is an one feedback connection is present from the output to the input. Then you are going to call that as a feedback neural network. If it is a feedback neural network, we are going to call that as a dynamic network. Why we are calling this dynamic network means it's going to give you the more accurate, and then you can able to store a temporal storage. With the help of the dynamic behaviors, you can able to identify with the help of this feedback neural network. Okay. So if you see the architecture, then you can able to know the feedback. See, from the hidden layers, one loop is going behind as an input. So if the anyone the connection is back to the input again, then you are going to call this as a feedback neural network. Sometimes depends upon the network model, from the output to input is going to happen, or sometimes from hidden layers to the input layer is going to take place. Depends upon the architecture. There are several network models are there. Example, Jordan network is there, Elman neural network is there. Likewise, they are differed in this feedback connection alone. Okay, so like this, different types of feedback networks are there. So depends upon the architecture, we are going to classify the type of the network. See the working principle of a dynamic neural network, which means the feedback neural network. Here x1, x2, x3 indicates the input, h11 and h21 indicates a two different hidden layers up to h31, and y1 is called as an output, fb1 is called as an feedback link 1. Likewise, the information is going to check whenever the actual output is equal to the desired one, the network is going to stop the learning. Till up to that, it is going to feedback the error signals from the output layer to the input layer again and again. Now, the comparison between the artificial neural network and then biological neural network. If you take a artificial neural network, only sequential processing is possible, because first it is going to complete the first process, then it is going to do the second process, then third process. But if it is a biological neuron, we can able to identify that parallel process are possible. At the same time, you can able to hear, at the same time you can able to speak, you can able to laugh. So parallelism is possible in the biological neuron. It is not possible in the artificial neuron. Okay. So even though the sequential processing is present in the artificial neural network, it have a high processing speed. But if you take a biological neuron, there is a low processing speed. If you give the example, if you ask the human to find out the difference between the colors, if all the colors are look like a same, it's very difficult to find out the different color from that color palette. But if you give the artificial neural network, it can able to find out the shape and then color, etc., very easily than that of the human. Okay, so even though the sequential processing is possible in the artificial neural network, but parallelism is possible in the biological neural network. Even though the parallelism is possible in the biological neuron, it has a low processing speed than that of the artificial neural network. This is the first difference between a artificial neural network and then biological network. Okay. So now the second one is called as the artificial systems are slow to converge. But if you take a biological neuron, it is easily able to find out, because once if you see the person, then after 10 years or after a year or after 2 years, after a 3 years, if we come, we can able to know very easily. Example, if it is a 2 years child, then the parents is need, the mother is going to show that this is the father, this is your uncle, this is your auntie, like that they are going to show. Then next, immediately the next time the same person is going to come in front of the child is going to remember that person very easily, and the child is going to call that father, mother, or what is that, uncle or auntie, anything is going to call, because the biological neuron, once if you take the input, the lifelong it's going to remember that, but it is not possible in the artificial neural network. So for artificial neural network, we need to give continuous training. After the continuous training only, the artificial neural network is going to behave like a human thoughts. So but if it is a biological neuron, the learning capacity is very fast than that of the artificial neural network. Okay. The third difference is artificial system is going to focus only one task at a time. But if you take a biological neuron, it can able to address different tasks at a time. Okay. So these are the three important comparison between the artificial neural network and then biological neural network. So many 10 points are there, but there is no time for us. So I'm going to the next slide. Okay. So learning process. So what is meant by learning process? Any idea about this? See here, assume that the child first time going to school, the teacher is going to tell how to put A, B, C, D, etc. Okay. So at the time of entering into the school first time, the LKG student or you pre-KG students don't know how to write in the slide or in the note. So now teacher is going to give training to the students. If it is a, the teacher is going to tell that one slanting line and another slanting line, one sleeping line. Okay, now the child automatically is going to put the one slanting line and another one slanting line and then one sleeping line. Now it's called a sun A. So the learning is going to take place in the children's mind with the help of the teacher. Okay. So now teacher is going to tell that E is there, one standing line, three sleeping lines. Then automatically E is going to present. So likewise, the learning is going to take place in the child with the help of this teacher. Okay. So now the child is going to learn that we are going to call this as a experience. At the first time of writing in the note, the child is going to scribble something, and he is not able to, he or she is not able to put a slanting line or a standing line nicely. Then through continuous learning process, which means a continuous training process again and again, the same child after 6 or 7 months, they know how to write a in the note very easily by through continuous assessment process of the teacher. Okay. So you are going to call this as a learning process. Okay. So likewise, the neural network also going to learn something from the environment with the help of continuous training. Okay. So here are anybody asks what is meant by learning process. The definition is learning is a process in which the network is going to adjust its parameter response to the input stimuli. Okay, so whatever the input going to given for the students, according to the student is going to develop its idea, and the suppose the teacher is not giving enough input to the students, then after 6 months also the same students is going to should not learn anything in the class. But if the teacher is giving good input, then the student also going to learn something. Likewise, the network also going to give the input stimuli. So according to that input stimuli, the weight is going to adjust. So this weight adjustment between the input layer to the hidden layer, the learning is going to takes place. Okay. So now whenever the learning is takes place, the actual output response converges to the desired one, then automatically the learning process is going to stop. So what is your actual output and what is your desired output? If it is a supervised learning, you need to give the actual output and then desired output, both of them. Now both them are said to be on same, then your network is going to stop the learning. So hereafter, if anybody asks you that what is meant by learning process, you need to give the answer that network is going to adjust its parameter according to the input stimuli. Okay. So now the actual response is converted to one desired output, then automatically the network is going to stop the learning. Till up to that, it's going to take on the input from the output layer again, it start to process again and again till up to the minimum square MSC is going to happen. Okay. See next one. When the actual output response is same as the desired one, then automatically the network is going to complete at the learning phase. And now we are going to tell that network has acquired it knowledge. Okay. So you are going to call this as a learning process. Whenever the network is not acquired any knowledge, then again and again the same process is going to takes place. So it may be we can able to apply this in both the forward network as well as feedback network also. So the learning process is common for all. What is the difference between the feed forward learning and then feedback learning means the one feedback loop is going to present from your output layer to the input layer. This is the difference. Okay. If you take a feed forward learning process, the learning process is going to takes place from in the forward direction alone. But here feedback is there. This is the difference. Okay. Whenever the actual output is equal to the desired one, the network automatically stops the neural network. Okay. Now, if the same teacher asking the kid that yes, write the ABCD. If the student write A to Z correctly, then the teacher is going to stop the teaching to the students. Likewise, the network also, whenever the actual output is equal to the desired output, then automatically it is going to stop the learning. If any one of the child is making mistake again and again, the teacher is going to correct the error of the following students individually. Then if the same student will complete all the all the letters from A to Z, then automatically the teacher is going to stop the learning for all the students. Now the network means here indicate the whole class acquire the knowledge, then automatically the teacher is going to stop the teaching, then he is going to jump to the next one. Likewise, the network also going to get the knowledge in this manner. So now this is called a learning process. Now how the learning process is going to occur in the neural network, if you take that with the help of the learning algorithm, the learning process is going to takes place. So what is mean by learning algorithm? The procedure, some of the procedures we are going to use to process the learning in the network, we are going to call that as a learning algorithms. So what is the work of this learning algorithm? If you take that, the input to hidden layer, it's going to modify the synaptic weights in between a input layer to the hidden layer. So when this learning is going to stop means whenever the actual output meet the desired design objective, then learning is going to stop. Otherwise it's going to do keep on, it's going to do again and again. Okay, you are going to call this as a learning algorithm. Okay, so using this learning algorithm only, the network is going to learn the information from the environment. There are different types of algorithms, learning algorithms are there. They are called as supervised learning, unsupervised learning, reinforcement learning, and one more learning is there, competitive learning. Several important learning method also there. Okay, so but we are going to focus only this four. Okay, because in the nowadays in the research area they are implementing this four different learning algorithms. Okay, supervised learning. Okay, so the supervised learning, if you take that, during the learning an input vector is applied to the network and it result in an output vector. So if you give the any input, it is going to produce any output. Okay, so how the input converter to output means, you have your one input, one output. Now your input is matched with this target. Okay, so here this target is called as an teacher. Okay, teacher is already favored, already know about the examples. So now teacher have your answer. Now this network is going to train again and again, and it is going to compare the answer produced by the network with the output already presented with the teacher. Now the network is going to do the action again and again. Whenever the teacher output and then target response is equal, now network is going to stop the action. Work of the teacher in the supervised learning means already the teacher is experienced with the output. So each and every iterations, the output given by the network is going to compare with the teacher. Now the actual output and desired output both are same. The supervised learning is going to stop the learning process. So if both of them are not matched, then automatically the network is going to learn again and again. Okay. See the next point. The response is going to compare with the target response. If the actual response differ from the target, the network is going to generate the error signal. Now error signal again is going to process and it is going to minimize the error in the next iteration, and another next iteration it is going to reduce the error signal. Likewise it is going to follow up to a minimum error. See now according to the error signal we are receiving, no, that according to that error signal the network is going to adjust its synaptic weights with the help of this supervised learning. Okay. So when this supervised learning is going to stop the process, the desired one, actual one equal to the desired one, which means desired one means whatever we fixed. Okay. When both of them are same, then the supervised learning is going to stop the learning. Okay. The best example for the supervised learning is a pattern recognition. Okay. So now the pattern recognition, the artificial neural network comes up with guesses while recognizing. Okay. Then now the answer is already with the teacher. Then the teacher is going to provide the ANN with the answer. The network then compares it with the teacher's output. If the teacher output and then our network output is compared, if both are different, then again it's going to adjust the error with the help of the synaptic weights. Now the process is going to start again. Okay. Whenever the both the signal and then teacher's output both are same, the network is going to stop the learning. So some of the examples of the supervised learnings are SVM called as an support vector machine, nearest neighbors, and decision trees, random forest, linear regressions. Okay. So these are the some of the examples for the supervised learning, and some of the applications we are using this supervised learning are bioinformatics, and then speech recognition, and then spam detection, object recognition for visions. So in this area we are implementing this supervised learning. Okay. See the example for the supervised learning, how supervised learning and
Machine
unsupervised is
learning is a
different.
type of AI that mimics learning and becomes more accurate over time without being explicitly programmed to do so. Think recommendation engines, a common machine learning application which gives you more tailored ads the longer it observes your clicking habits. The two most common approaches to machine learning training are supervised learning and unsupervised learning. Supervised machine learning requires a data scientist to train the algorithm with labeled inputs paired with desired outputs. For instance, a shape with 3 sides is labeled as a triangle. The goal is that the algorithm can eventually take in new inputs and independently predict the correct label for the data. Supervised machine learning is ideal for binary classification, multi-class classification, regression modeling, and ensembling. Unsupervised machine learning does not require a data scientist to provide labels and corresponding outputs. Instead, the algorithm sifts through unlabeled input data and identifies patterns that it will use to group data, like how many sides a shape has. It's unsupervised because there are no teachers and no right or wrong outputs. The algorithm is responsible for analyzing the underlying structure in the data. Unsupervised learning is ideal for clustering, anomaly detection, association mining, and dimensionality reduction. Supervised learning is the more common of the two machine learning techniques. It provides accurate results but can be complex, time-consuming, and expensive to compute. Unsupervised learning is less complex and takes place in real time, but is also less accurate.
So now unsupervised learning, it's totally different from the supervised learning because here there is no teacher is present, which means already experienced output is not present in the unsupervised learning. But if you do this network model, it's going to apply some logics and it's going to cluster the data. Okay. So even though unsupervised learning training does not require a teacher, it requires some guidelines to form a group. If you see the this type of learning is going to require when there is no example data set is known because there is no teacher here. That's why there is no already planned output is not here. So there is no teacher in the network. We are going to call this as a unsupervised learning. Okay. See the first point, in contrast to supervised learning, unsupervised learning does not require a teacher. Why it does not require a teacher? The first one, supervised learning, it have a teacher, which means already the teacher is experienced. So he know what is the error is going to take place in the network. So such time you are going to use the supervised learning. Here there is no teacher. So, okay, without teacher, the network is going to cluster the data according to some clues, whatever which is present in the network. Okay. So if you take this, input vectors of similar types are grouped without use of training data, and it does not tell how the members look and what is the difference between this. But even though it is going to use some logics and it is going to group together, you are going to call that as a unsupervised learning. Okay. If you take a supervised learning, there is an teacher. If it is an unsupervised learning, there is no teacher. Okay. clustering, visualization, dimensionality reductions, association rule mining, and anomaly detection. Already, so all are familiar with this word clustering and then visualization, dimension reduction, dimensionality reduction, and then association rules. These all are the best examples for the unsupervised learning. Some of the applications nowadays we are using no called as an similarity detection, and then some of the recommendation systems, and then customer segmentations are the latest applications we are using this unsupervised learning. The next one is called as an reinforcement learning. So if you take a reinforcement learning, it consists of four components. They are called as an agent, and then action, environment, and then a reward. If you see this four component, the agent is going to take the input and it is going to process the input, and according to the environment it is going to produce the output. Desired output. Now, in this type of learning, the four components are individually acting as an agent. Okay. So the first one is called as an input. Whenever if you give the input, the agent is going to take the input and it is going to perform some action according to the environment. Now something, and then now it is going to produce one output for us. So from this output again, the agent is going to take us an input, then it is going to perform some action with the help of the environment. Now again it is going to produce some output. So this output is going to given us an input to the agent, and then now again another action is going to take place according to the environment. Now it is going to produce the output. So till the input output and the according to the environment is going to take place, whenever the actual output is equal to the desired output, then the network is going to stop the network evaluation. Okay. So this is applied in the self-driving car. Okay. We are going to see some examples again. Okay. So with the help of the environment, it's going to observe whenever if you get the negative output from them, then automatically the network is going to compare the output with the environment. Again, it is going to take some actions, and finally it is going to give the positive decision for us. Okay. We are going to call this as a reinforced learning. Okay. So in this type of learning, it does not indicate how the output is actually close with the desired output, but it is going to give the pass or fail indication for us. If the output is on pass, then network is going to stop. If it is a fail, then again it start to learn from the environment up to that pass condition is going to occur. Okay. So examples of this reinforcement learning is on self-driving car and personalized video recommendation and AI-powered stock buying selling applications, like some of the healthcare, marketings, and robotics are using this reinforcement learnings. Okay. Now I am going to show the comparison between these three types of learning.
Hello everyone. Welcome to this tutorial by Simply Learn. In this video, you will learn about an interesting machine learning topic, that is supervised versus unsupervised versus reinforcement learning. Let's discuss each of them in detail and understand when to use these algorithms along with their applications. Now, there are a number of algorithms used in the field of machine learning to solve complex problems. Each of these algorithms can be classified into a certain category. So the different types of machine learning algorithms are supervised learning, unsupervised learning, and reinforcement learning. Now, let's look at the definition of each of these learning techniques. Supervised learning uses labeled data to train machine learning models. Labeled data means that the output is already known to you. The model just needs to map the inputs to the outputs. An example of supervised learning can be to train a machine that identifies the image of an animal. Below you can see we have our trained model that identifies the picture of a cat. Unsupervised learning uses unlabeled data to train machines. Unlabeled data means there is no fixed output variable. The model learns from the data, discovers patterns and features in the data, and returns the output. Here is an example of an unsupervised learning technique that uses the images of vehicles to classify if it's a bus or a truck. So the model learns by identifying the parts of a vehicle, such as the length and width of the vehicle, the front and rear end covers, roof girds, the types of wheels used, and etc. Based on these features, the model classifies if the vehicle is a bus or a truck. Reinforcement learning trains a machine to take suitable actions and maximize a reward in a particular situation. It uses an agent and an environment to produce actions and rewards. The agent has a start and an end state, but there might be different paths for reaching the end state, like a maze. In this learning technique, there is no predefined target variable. An example of reinforcement learning is to train a machine that can identify the shape of an object given a list of different objects such as square, triangle, rectangle, or circle. In the example shown, the model tries to predict the shape of the object, which is a square here. Now, let's look at the different machine learning algorithms that come under these learning techniques. Some of the commonly used supervised learning algorithms are linear regression, logistic regression, support vector machines, k-nearest neighbors, decision tree, random forest, and naive Bayes. Examples of unsupervised learning algorithms are k-means clustering, hierarchical clustering, DB-scan, principal component analysis, and others. Choosing the right algorithm depends on the type of problem you are trying to solve. Some of the important reinforcement learning algorithms are Q-learning, Monte Carlo, SARSA, and Deep Q network. Now let's look at the approach in which these machine learning techniques work. So supervised learning takes labeled inputs and maps it to known outputs, which means you already know the target variable. Unsupervised learning finds patterns and understands the trends in the data to discover the output. So the model tries to label the data based on the features of the input data. While reinforcement learning follows trial and error method to get the desired solution. After accomplishing a task, the agent receives an award. An example could be to train a dog to catch the ball. If the dog learns to catch a ball, you give it a reward such as a biscuit. Now, let's discuss the training process for each of these learning methods. So supervised learning methods need external supervision to train machine learning models, and hence the name supervised. They need guidance and additional information to return the result. Unsupervised learning techniques do not need any supervision to train models. They learn on their own and predict the output. Similarly, reinforcement learning methods do not need any supervision to train machine learning models. And with that, let's focus on the types of problems that can be solved using these three types of machine learning techniques. So supervised learning is generally used for classification and regression problems. We'll see the examples in the next slide. And unsupervised learning is used for clustering and association problems, while reinforcement learning is reward based. So for every task or for every step completed, there will be a reward received by the agent. And if the task is not achieved correctly, there will be some penalty used. Now, let's look at a few applications of supervised, unsupervised, and reinforcement learning. As we saw earlier, supervised learning are used to solve classification and regression problems. For example, you can predict the weather for a particular day based on humidity, precipitation, wind speed, and pressure values. You can use supervised learning algorithms to forecast sales for the next month or the next quarter for different products. Similarly, you can use it for stock price analysis or identifying if a cancer cell is malignant or benign. Now, talking about the applications of unsupervised learning, we have customer segmentation. So based on customer behavior, likes, dislikes, and interests, you can segment and cluster similar customers into a group. Another example where unsupervised learning algorithms are used is customer churn analysis. Now, let's see what applications we have in reinforcement learning. So reinforcement learning algorithms are widely used in the gaming industries to build games. It is also used to train robots to perform human tasks. And with that, we have come.
Okay. So the next last type of learning is called as on competitive learning. So if it is a competitive learning, it is coming under a category of unsupervised learning. Okay. Used in the machine learning and then artificial intelligence systems. Okay. So why we are calling this as an unsupervised learning means here also there is no target is here. So only one output neuron is active at a time. The neuron that wins the competition is called winner take all the neurons. Okay. So the competitive learning is called as a winner take all networks where only the neuron that best represent the input is allowed to learn. Since all the neurons learn to better represent the kind of inputs they already are good at representing, they began to represent different kinds of inputs. For example, if you give the vector valued input and representation, the input become quantized to the unit having the closest representation model. And these representations are adapted to minimize the representation error using the sum of the gradient descent algorithm. If you take a n number of neurons which is present in the network, only one neuron is going to come forward and it is going to complete all the learning process. Then you are going to call this type as a competitive learning. Okay. So if you take a Hebbian learning, several neurons are going to take part in the learning process. But if it is a competitive learning, the difference is that only one neuron is going to overtake all the neuron, and that overtaken neuron is going to take the full part and it is going to complete the task. If the learning is going to take place like that, then you are going to call that as a competitive learning. Okay. So this is the last video I'm going to display for you.
So let's start with the con. Hello, friends. Welcome to Engineering.
Okay. So now we are going to learn the what is the learning rules applied in the competitive learning we are going to discuss. Okay.
Tutorial. So we'll continue our discussion with the subject of neural networks, and we're discussing about the basic learning rules. So in this video, we are going to discuss about another important learning rule which is used for the training or the learning process neural networks, which is competitive learning. So as the name suggests, all the neurons involved in the process, they engage in a competition here, okay, in this whole process of competitive learning, in this whole mechanism. So the basic learning mechanism, as we all know, it involves the neural network being provided with new input, being stimulated by the environment, supplied with new stimulus, and in order to adjust itself to the new environment, it has to change in weights associated between the synaptic connections or the change in the overall structure. So in competitive learning, what happens is that we have a neural network consisting of a single layer of output neurons here, the filled with black, the large size circles, they're the output layer of neurons and the input layer of neurons. For simplicity, I have taken this simple structure, and they are connected with every other neuron possible through synaptic connections, and each of these synaptic connections, they have certain weights associated with it marked by these arrowheads. And all the output neurons also, they are connected to
each other through synaptic connections. So here, the output layer of neurons, they participate in a competition where a particular neuron with the maximum net input, okay, the maximum net input, that is the winning neuron. Okay, so it is very much similar to, a student with who secures the maximum marks in the exam comes top of the class, or in a competitive exam, candidate scoring maximum marks secures the top rank, the first rank. So, or in a general sports competition, the player with the maximum points wins. So, like that. So it's a winner takes all kind of a thing. So here all the output layer of neurons, they engage in this competition. So here in nodal representation, we can say if we pick a particular neuron out of it, the net input, the total input is the resultant or the sum of all the individual inputs that are given to that particular neuron multiplied with their synaptic weights, and that total is called as the net input or combined input or induced local field. So the neuron with the maximum net input or combined input or induced local field, that is the winning neuron, the neuron which wins the competition. And the output of that winning neuron is set to 1. Suppose here the first neuron has the maximum net input. So the output of that neuron will be set to 1. And these two neurons, it will be set to 0. Suppose the second neuron, a second output neuron wins the competition. Then the output value of this neuron will be 1. And the top and the bottom neuron, it will be 0. Suppose the bottom neuron wins the competition. Then that will be the output of that neuron will be 1, and the first and the second neuron will be 0. So it is kind of this. So mathematically, we can represent it that the neuron for which the induced local field Vk, as I said, I've already discussed in the previous videos also, the net input or combined input is represented as Vk, the induced local field, and n here represents a particular instant of time. So in a particular instant of time n, if the induced local field for the kth neuron, okay, the kth neuron is greater than all the remaining neurons, then the output value of that kth neuron will be 1 and all the other neurons will be 0. Okay, so this is the whole concept of competitive learning. So this whole thing is a competition. Now, the application of the
Okay. So this is the differentiation. Already we saw in the video, the same thing present here also. Okay. So now I'm going to display some program using the MATLAB. I'm going to show you one neural network program with the help of the MATLAB. Okay. See here, this is the general syntax. Whenever if you try to write the code in the MATLAB with the help of this, if you try to create a feed-forward neural network in the MATLAB, you need to follow this general syntax. Okay, net equal to new FF. So this new FF indicates that new feed-forward neural network, and you need to set a P as a input vector and T is a target. Then SI is called as an input hidden layers. Then TFI is called as an transfer function. This is by default, it is an transig for the hidden layers and pure linear function for the output layer. Okay, if you need to use this same setup, if you need to change the setup, then you can able to change the setup, no issue. Depends upon your input and then target, you can able to change this default setting. Okay, see the next parameters. The next parameter indicates that a BTF called as an backpropagation training function. So this is a default backpropagation training function is on train LM. And then BLF is called as an back propagation learning function. The default function is on learn GDM. And then PF called as an performance function. Defaultly it is depend MSC. And then IPF is called as an information input processing functions. Defaultly we have a fix unknowns, remove constant rows, and map minimum maximum. Okay. Now the next one is called as an OPF, called as an output processing function, and default equal to the your defaultly we are going to set that remove constant rows and map minimum max. Okay, you should not change the setups whatever which is present defaultly. Okay, then DDF is called as an data division functions. Defaultly it is set as an divider and. So now this is the general syntax we discussed now. I applied this general syntax as a program in the next slide. See here. So the clear all is going to clear all the variables, whatever which is present in the location of the MATLAB. Then CLC is to clear the variables in the commands. Then I fixed the input and target is there. Okay, now I created the network with a new FF, called and feed forward neural network with a input and then target with 5 hidden layers, which means five hidden neurons. Then I try to simulate the network with the help of our input. Okay. So I asked the network to train the maximum training limit is on 50 iterations. Now so I start to train the network. Now I simulated the network again. See the output. If I execute this one, we are going to get the output like this. Can you able to see the MATLAB window now?
Yes, sir.
Yes, okay. See here, clear all CLC is there, input vector is there, target is there. I created the new feed forward neural network and simulated the network. See the output. I am going to click this run. Now it is going to produce the output for us. See in the sixth iteration, the training is going to stop. Okay. See now again I am going to click this. Now the seventh iteration. Likewise, the iteration is going to change whenever the learning, the input is equal to the, which means actual input is equal to the desired output, the network is going to stop the learning. We can able to see the performance of the network by clicking this tabs and then a regression also. Okay. So now we are going to I'm going to end the slide with one more video. Okay. So what is meant by intelligent? So intelligence is nothing but an abstract thought, ability to learn, understand, and making judgment based on any one reason. We are going to call that as an intelligence. This intelligence is going to take place in this following manners in the network. Okay. So in the machine, the following intelligence is going to take place in this manner. But we are a human beings. How intelligence is going to occur through human beings means from vision it is on 70 percentage, and from hearing it is on 30 percentage. You are telling that the child, 2 years child, that see we have one biggest animal called as an elephant. It's look like a black or brown color. It have a trunk and it have a four legs. It's walk with the four legs. It have the two eyes. Long trunk is there like that. If you tell the child tell that okay, okay, okay. Then after 10 to 15 days, if you ask the structure of the elephant, the child will not tell that same thing. But instead of that, once if you show the elephant in front of the child, then the child is going to learn the structure of the elephant very easily. the next time the same elephant is going to come in front of the child is going to shout like that, elephant, elephant, elephant. So the intelligence is going to occur for the child with the help of 70 percentage, and from the hearing it is on 30 percentage. Anyway, so the ability to learn and understand and making a judgment based on any previous reasons, we are going to call that as a intelligence. Now we are coming to the artificial intelligence. So the artificial intelligence is a technique is going to mimic the problem solving skill of a human mind. We are going to artificially, we are going to give some instruction to the machine, and now the machine is going to behave like a human. Whenever any problem is going to occur, the machine is going to take a decision like how human beings is going to take a decision at the time of problem. We are going to call this as a artificial intelligence. We are going to give this artificial intelligence to the machine with the help of continuous training. Okay, see, so this video is called as an electroencephalogram based wheelchair I developed. Now we are doing the research in this. We are giving the artificial intelligence to this wheelchair. Whenever the subject need to move forward or some other direction, they need to pronounce this word. Then automatically, with the help of this artificial intelligence, the following wheelchair start to move in the four direction. We are going to see this one. Okay, we embedded the artificial intelligence concept with the help of neural network to the brain computer interface. This is the last video. See,
I'm just a thug on the other side of the law.
okay. So we embedded this artificial intelligence in the machine in the indoor environment. Okay. So now with the help of continuous training, we can able to make the machine to think like a human. So that's all. I'm going to complete my presentation. So dear participants, if you have any further doubt, you can ask regarding the neural networks.
Thank you, sir. Participants, do you have any questions? Sir, I hope there is no questions. I think we can end the session, sir.
Okay.
Yes, sir. Thank you for delivering this wonderful knowledge on this such complex neural networks. Actually, we had a good learning experience today, sir. And we really thank you for sparing your valuable time and the efforts taken by you for sharing your knowledge to us. Thank you, sir. Thank you. And the participants, the feedback link is posted in your chat box. You can fill in the feedback.
Thank you, Ramkumar.
Thank you so much, madam.
Thank
for
you.
giving
Thank
this
you so
opportunity.
much. No, it's really an excellent and wonderful presentation. So, still, even I got so many ideas, and I to learn many things through your. Thanks a lot. Thank you
I'm
so
receiving
much.
feedback, Professor, now. I'm receiving the
Oh,
feedback from
super.
the participants.
Oh, super. Very nice. Yeah. It's really good. Really enjoyed. Thank you. Thank you so
Thank
much.
you.
I
Thank
know
you.
you are a busy schedule. I know how much in the difficult situation you are there. Still, you accept our invitation and you spare your time along with us. Really, it's a great thing. Thanks a lot. Thank you so much, ma'am.
Thank you so much, ma'am. Thank you so much, ma'am.
Participants can fill your feedback and let us meet tomorrow at 2 p.m.